And today we're going to do your first virtual lab. All right, so we did the warm up and an instruction last week after the quiz. And so today we're going to jump into the lab portion here. And so on the virtual lab page, on that tab, if you open that up, what you're going to find is that on by about slide number seven is going to give you the link where it says here to launch the simulation in order to complete the actual experiment. When you click on that link where it says here, finally in slide number 7 of 8, it will open up another screen that looks something like this. We're going to use this virtual lab to then complete the information we have in our chart. Now, on your tables, you should have your lab procedures, which has step 1 and step 2 and step 3, which is a lot of reading, I know, and 4. And then you should have the paper we're going to actually stamp and collect, your data collection points. This page, which is front and back, is the most important. We're going to be collecting data in table A for the cart on low fan speed, medium fan speed, high fan speed. And then we're going to be doing some calculations to find the elapsed time, the total distance, average velocity, and finally acceleration in table B. And then we'll reflect on some graphs, some observations. In this section here, you're just going to be writing down some notes, some sentences to explain what you see. And then some observations here finally for the last thing at the end of the lab. All right, so we're going to be filling out these forms here, but your directions are pretty straightforward. Let me kind of run through them with you because it looks like a lot, but it's the same thing over and over again. All right, so if I go back to the virtual lab, essentially what we're going to do is we want to make sure that our fan is going to be on either low or medium or high. Those are the three different experiments you're going to run today. We do not have to worry about any of the objects. We're not dealing with extra objects there or what we would call mass. So we're not worried about objects, but we do want to make sure that our friction is set at no friction. Right now, you can do metal, cement, wood if you want to play with it later, but we're going to do no friction and we're going to do a low speed. And the idea is that we're going to have a consistent experiment here where there's no friction every single time, and we're just looking at the fan force. And as you talk through this, the fan becomes the thing that we are able to manipulate or change, right? So it's the thing that is going to be the independent variable in our formula. What we don't know is how that fan is going to affect something else in terms of how it affects velocity and acceleration. Those become dependent elements there. You can see down below, you have the fan, the little cart on a fan here, and there's a flag. If you were to press the play button, whoop, like so, you can see the cart moving, and the cart's going to move and cross the finish line where that fan is at. In doing so, on the bottom left, you'll notice a time stamp down here next to the play button, 7.4 seconds, and you have the fan there. That's the experiment with low fan force, no friction. You go, okay, great, that's the experiment. The data is going to be over here in the data point. So that process there of just having the low fan, no friction, and pressing play is what the experiment is. You do that for low. You'll then do it again for medium, and to reset it, you press the reset button, you run it for medium, it does it again, right? And then you'll do it again for high by resetting and pressing play. Now, for now, what I'm going to do is I'm going to go back to the low because that's the experiment there. And you press play, and I'm going to go ahead and just drop. Well, I'll leave it like that. I'm going to put it on wood for now, just so I don't give you the answers. All right. So here we go. So I'm going to put wood. Don't do wood. You're doing no friction. And I would press play, let the experiment run. Ooh, a little bouncing on the wood there. That's great. You're going to let your experiment run on low with no friction. And then you'll go to the data. The data tab, you have experiment, data, experiment, data. The data tab is going to give you your information that you're going to use to fill in your table. The information here in the speed data is going to be the time is 0, the speed is 0, time is 1, speed is 8.2. That information there you're going to put into table A. And that's what you're going to fill in for the low and later on for the medium and the high. You use that data, of course, to then figure out what goes in table B. Your elapsed time is going to be down on the bottom next to the play button, which will tell you in this case it was 11 seconds. Your total distance is always going to be where the flag is at. So that's 500 centimeters there. And then the calculation part. Average velocity is going to be your total distance, which is 500, divided by your total time, which is going to vary depending upon which experiment you're running. In this case, it would be like 500 divided by 11. You'll calculate that out. And then you'll figure out the acceleration based upon those data points as well. All right, so keep that in mind. And then once you've done that, I think part C is going to have you then switch from speed to position, speed to position. And on the speed to position thing, you'll start to see a little difference here in how this works. It should be a line graph, I apologize. You'll see a different, this is like upward kind of flowing. It's not a linear thing, so it's curved. You're going to describe what you see happening there with that data point. So that's the idea behind the experiment in the lab. And again, when you're done with that, you would reset it. You'll switch back to speed. You'll go back to the experiment, and then you're going to go to the medium and then do it again. All right. So that's kind of the idea. You're writing observations down. You put your data in A, do some math in B, you do your observations in C, and then there'll be another one in D as well. So make sure your calculations are right. There will be a place for you to enter your result as you move through the lab. So make sure you're taking good notes. We'll stamp that paper that you have, so that'll get stamped for your credit. And then you'll also be moving forward in the lab itself, and Edgenuity will grade you as you do this and give you a score when you're all done. So for example, if I was to look back at my score here, go back to my home page, open up my little tab and my map, I can see that on my lab, I have a 95.2% on my virtual lab. Why is that? Well, there was one question that I didn't have the right rounding. I wanted to the nearest tenth. And actually, one point question, I had the wrong number down too. And so it actually is scoring it. So you want to make sure your answers are correct because that becomes your lab score. All right, that's it for today. Have a great time on the lab. Make sure you get your data points all filled out and then complete the whole lab all the way down to the summary part, and you'll be good to go. Good luck.